Hi everyone, welcome to our channel. My name is Mo, and today we are diving into some fascinating C# fundamentals that every programmer should know. Whether you're a beginner or looking to refresh your skills, this session will be super helpful. Today we will cover in, out, ref, string type, boxing, and unboxing. Those are really interesting topics. So let's get started. Let's kick off by talking about the ref keyword. Let me draw the memory structure. At top we have stack and at the bottom we have heap. This is the memory structure in the C sharp. Here I have a variable which is a value type and I'm using the ref keyword in the increment method. So when I'm defining this variable in the stack, it's going to store the number 5 as a value. And when I'm calling the increment method, because of using the ref keyword, its reference will be passed through the increment method. And when I'm increasing and changing this variable, the original value will be changed because its reference has been passed through and it's not going to create a new variable in the stack. Now let's talk about out and in keywords and what are the differences between these two keywords. Out and in are subset of the ref keyword, but what are the difference really? As you can see in this example, I have used out keyword in the get values and I have two variables which are value type x and y. Here, by calling the get values, I'm passing through the reference of these two variables because they're using the out keyword as you can see here. So reference will be passed through. Here, as you can see, I'm passing through the reference of these two variables. And in the get values method, I'm going to replace original value with new values, in this case 1 and 2. And these two values will be replaced by its default value. Because I have used the out keyword, the reference will be passed through. And first, I must initialize it. Otherwise, I can't use some operations like incremental. Otherwise, the compiler will throw an error. I should mention that we have another syntax which is a little bit better. Let me comment these two variables and change the syntax to something like this. We can use this approach if we wanted, but they are completely the same. Out stands for output and it's a write only. So let's see what is in keyword. Here in this example, as you can see, I'm passing through print value this variable and it's using the in keyword. In stands for input and it's read only. So it means that I can't change the value at all. And if I try to change the value to something like this, the compiler will throw an error because it's not supposed to get changed. It's read only. Previously, we covered implicit and explicit conversion. When it's implicit, compiler can safely convert the value. For instance, here where I'm trying to convert into long, compiler can safely do that conversion. But when it's explicit, we might lose the data. So I must explicitly ask compiler to convert this value. In the realm of value type, implicit and explicit falls under the category of convert. So when it's value type, we're converting the variables. But what about the reference type? In case of reference type, we have implicit and explicit under the category of casting. So for reference type, we are using the casting term. We have upcasting and downcasting. Upcasting for implicit and downcasting for explicit. But what is the difference between upcasting and downcasting? Consider that we have two classes, a parent and a child. For instance, A is a parent class and B is a child class. When I'm trying to convert from B to A, it's upcasting. But when I'm trying to convert from A to B, it's downcasting and it's explicit, but that one is implicit. Now let's talk about boxing and unboxing. Boxing is process of converting value type to reference type. Let me draw the memory structure. At top we have stack and at bottom we have heap. Here in this example, I have a value variable and it's storing 1, 2, 3, and I have a reference type. Reference type at stack, I'm going to store the address, and in the heap, I'm going to store the actual value. And when I'm trying to convert this value type to reference type, actually, I'm going to convert value from stack to heap. So 1, 2, 3 will be stored in the heap. This process, I mean converting from stack to heap, is called boxing, which is implicit process because compiler can comprehend how much space is needed. On the other hand, reverse process is called unboxing, which means converting something from heap to stack. Because in that process, compiler has no clue about how much space is needed, so it must be explicit. We must explicitly instruct compiler to convert this reference type to value type. These two processes, boxing and unboxing, are heavy processes, so we must avoid it as much as possible. Now let's talk about strings. The strings are reference type and they are immutable and thread safe. But what does it mean? Let me draw the memory structure. At top we have a stack and bottom we have a heap. So in this example, I have a variable name, which means in the stack I store the address, and in the heap I'm going to store the actual value, which is Mo in this case. So here when I'm replacing Mo with John, the thing is happening in the heap, another space will be allocated and John will be stored there and its address will be replaced in the stack. So the former space will be there until GC starts releasing that space. Otherwise, the former space is always there. So here in this example, when I'm using the dot to upper, it means that in the heap, a compiler will create a new space and store John upper John there. So it will occupy a new address, and we should be mindful about this behavior for some scenarios like for each. For instance, as you can see here, I'm doing for each. So for 10 times, it's going to create a multiple space for this variable, and it's completely inefficient because it's going to occupy a lot of memories until TCS are releasing all those spaces. So to resolve this issue, we have a string builder, and it's not going to create a lot of spaces for us. So it's an efficient way of dealing with these kind of scenarios. And now we are going to take a look at the string interning. What does it mean? So here in this example, as you can see, I have two variables, A and B, with the same value. The thing is, when I'm calling reference equal, the result is true, which is really weird, isn't it? Because it should be false. There are two different variables. So the answer is in the memory structure. Let me draw the memory. As you know, in the bottom of the heap, we have high frequency heap. And in the heap itself, we have two more categories, small object heap and large object heap. And there could be a reference between SOH and LOH. Consider that I have a class with ID and name property. ID is type of int, so it will be stored in the SOH, but name is going to be stored in the LOH. SOH is for a small object, so GC will be tune and compact that part, but LOH no, it's going to consider it as a large object pool. So in the LOH we have interning. And in the interning, when in this example I'm going to store hello in the A, it's going to get stored in the interning. And for the second time, because it's a large object heap, compiler is not going to create another space. It's not going to occupy another space. And it's going just to use the current space because they're exactly the same. And it's perfect for tuning. And that's why, because they're pointing the same position and same location. When you're going to compare the references of these two variables, they're exactly the same. And that's a wrap. Today we covered some fundamental C# concepts in, out, ref, boxing and unboxing, and strings. These tools and techniques are essential for writing effective, efficient, and clean C# code. I hope you found this session helpful. If you have any questions or need further clarification, feel free to leave a comment below. Don't forget to like, share, and subscribe for more programming tutorials and tips. Thanks for watching and happy coding.